welcome to this deep dive into the world of data science and machine learning platforms.
Yeah.
Now, you sent over some really interesting stuff, a report that looks at specific platforms and how they license out their tech. And then we also have that Gartner Magic Quadrant, which, kind of paints a bigger picture of the market as a whole.
Yeah, definitely. I think this deep dive will be great for unpacking not just what these platforms are, but like how they're actually being used and how they all stack up against each other. By the end of this, you'll have a way better understanding of the whole, DSML platform landscape.
Yeah.
And you can use that to make better decisions. Or, just impress your friends with random data science trivia at parties.
I love that. So before we get too far into it, can we just define, what is a data science and machine learning platform? I know we've talked about this before.
Yeah.
But it's worth revisiting.
For sure. Yeah. Especially with all the new stuff that's coming out. Gartner defines it as like a cohesive set of tools that support collaboration throughout the entire data science lifecycle. Yeah. And that's key. It's not just building models. It's about, understanding the business problem and sharing insights and all the technical parts too.
Okay. So it's like a comprehensive toolbox for data professionals. But what are some examples of what they can do, like in the real world?
So many examples. Like imagine you're a retailer and you want to predict demand for the upcoming holiday season. A DSML platform could help you analyze your historical sales data, factor in external trends, and generate some super accurate forecasts. Or let's say you're a financial institution trying to detect fraud. These platforms can use machine learning to find suspicious patterns and flag potential fraud in real time.
Wow. So it's a really wide range of tasks across different industries. So I'm starting to see why these platforms are getting so popular. What are some of the platforms that you see out there?
Well, the stuff you sent, it highlights some of the big ones. Databricks, DataRobot, Cloudera, IBM's WatsonX, and SAS Viya.
Yeah, those names all sound familiar. But are they all created equal? Or do they have strengths and weaknesses?
That's a great question. And that's where that Gartner Magic Quadrant comes in. It puts all these vendors into 4 different quadrants: leaders, challengers, visionaries, and niche players. And it bases these categories on their ability to execute and completeness of vision.
So it's not just who's the most popular. It's like a deeper analysis of their potential.
Exactly. Like AWS is considered a leader, known for its massive scale and its comprehensive suite of cloud services. But some users might find it overwhelming just because of its sheer size and complexity. Databricks is another leader that's known for its unified platform, which combines data warehousing, data engineering, and machine learning capabilities.
Okay, that makes sense. I'm also interested in how these platforms are kind of all interconnected. The source material mentioned something about licensing models.
Yeah, so some platforms actually let other companies offer licensed versions of their technology. Like for instance, you might be using Databricks without even realizing it through Microsoft Azure's version of it.
Oh, really? So I could be using a platform that's powered by another platform behind the scenes.
Exactly. And these types of partnerships are getting super common. It lets companies leverage the best parts of different platforms to get customized solutions that really meet their needs.
That's so interesting. It seems like these platforms aren't just competitors, but they're also collaborators in a way, trying to find the best combination of tools for any job.
Absolutely. And that's what it's all about, finding the right tool for the right job. There's no one-size-fits-all solution when it comes to data science and machine learning.
So if we're talking about choosing the right platform, what are some of the key differences that we should keep in mind?
Yeah. You've hit the nail on the head. Choosing a DSML platform, it's not one size fits all. It depends on your needs, your resources.
And your goals. Okay, so let's break that down a little bit. What are some of the strengths and cautions of each of these platforms that we mentioned?
All right, let's start with Databricks. One of its biggest strengths is its unified approach. It combines data engineering, data warehousing, and machine learning all into one platform, which is a huge advantage for companies that want to streamline their data workflows and not have to juggle multiple tools. But some users say that managing Databricks clusters can be complex and requires specialized expertise.
Okay, so Databricks is powerful, but it might have a steeper learning curve. What about DataRobot? How does that compare?
DataRobot is all about accelerating time to value. For AI projects, they have a really user-friendly interface, and they really focus on automated machine learning. So it's easier for business users, even if they don't have a lot of coding experience, to build and deploy models quickly. But that ease of use can sometimes come at a higher cost compared to other platforms.
Interesting. So DataRobot is kind of like the express lane for data science, but you might pay a premium for that speed. Now, what about Cloudera? What are they known for?
Yeah. Cloudera stands out because of its flexibility. It works across hybrid cloud, multi-cloud, and on-premises environments, so it's a good choice for organizations with complex data architectures or ones that are still moving to the cloud. One thing to note, though, is that while they do offer low-code features, they're not as mature as some of its competitors.
Okay, so Cloudera is like
Yeah.
the adaptable option,
Mm.
but the low-code capabilities are still kind of evolving.
Yeah.
All right, so you've got IBM's WatsonX next. What's their story?
Openness and flexibility are key for WatsonX. It's a good choice for organizations that are already using IBM's ecosystem and has a wide range of tools and services that integrate well with existing IBM solutions. But some users say that their pricing structure is a bit complex and difficult to figure out.
Okay, so it's good for the IBM fans, but maybe less transparent for people who are new to it. Okay, last one. SAS Viya. What are their strengths and cautions?
SAS Viya is known for its scalability and its ability to handle huge volumes of data. It's a really robust platform that's been used in enterprise analytics for years. They have a flexible licensing model that allows it to be deployed across different cloud providers and on-premises environments. However, some users say that SAS Viya can be more expensive compared to other platforms, especially for smaller organizations or ones with limited budgets.
Okay, so SAS Viya is for those big data challenges, but it might not be the most budget-friendly option for everybody. This is so helpful. It seems like each platform has its own unique strengths and weaknesses, and the best choice really depends on the specific needs of the user.
Exactly. And it's not just about the technology either. It's also important to consider the community and the support that comes with each platform. Some platforms have more active user communities and better documentation and resources. And of course, a good support team can make a huge difference. When you run into problems...
That's a great point. It's like having a network of experts to help you out. It's also interesting to see how some of these platforms, like Databricks, DataRobot, and Cloudera, let other companies offer licensed versions of their tools on their own platforms. It creates a really interesting dynamic.
Absolutely. It shows how these companies are both competitors and collaborators. They're always pushing the boundaries of what's possible with data science and machine learning, and this is only going to become more common in the future.
It seems like the data science landscape is always evolving, with new platforms and technologies emerging all the time. So how can someone stay ahead of the curve
Yeah.
and make sure they're making the right choices?
Well, the most important thing is to stay informed. Read industry publications, go to conferences, and follow thought leaders. That way you can keep up with the latest trends and advancements.
Okay, so knowledge is power. What else can someone do?
Don't be afraid to experiment. Try out different platforms, play around with different tools, and see what works best for you.
So it's not just about studying. It's about actually getting your hands dirty.
Yeah.
And trying things out.
Exactly. And remember, there's no right way to do data science. It's about finding the tools and approaches that help you achieve your goals.
This has been so helpful. We've covered so much today. From defining what a DSML platform is, to exploring the strengths and cautions of these different platforms. I think our listeners will have a much better understanding of the landscape now.
Yeah.
But before we wrap up, there's one more thing I wanted to talk about. The rise of generative AI and its impact on data science workflows.
Oh, yeah. Generative AI is everywhere these days.
It really is. So what does it actually mean for data science?
Well, it's fascinating because it represents a shift from just analyzing data to actually creating data. We're talking about algorithms that can generate text, images, code, even music. It's opening up all these new possibilities.
So instead of just predicting what will happen, we can use AI to imagine what could be. I'm curious about the real-world implications of this in data science. Can you give us some examples?
Definitely. Let's say you're developing a model to detect medical conditions from X-ray images, but you don't have enough real patient data to train it. Generative AI can actually create synthetic X-ray images that look like real cases, so your model has more data to learn from.
Wow. So it can help with data scarcity and privacy issues. What other applications are there?
Think about financial modeling. Generative AI can create realistic simulations of market scenarios, so analysts can assess risk and make better investment decisions. Or in marketing, you can use it to generate personalized content and product recommendations.
Sounds like generative AI has the potential to to really revolutionize a lot of industries. But how are these DSML platforms incorporating these advancements?
They're evolving. Like, for example, Databricks acquired MosaicML, a company that specializes in generative AI. And this lets Databricks users train and deploy large language models much more efficiently.
Oh, wow. That's a great example of how these platforms are adapting. To stay ahead of the curve, it's like they're constantly adding new tools to their workshops
Yeah.
to help data professionals.
Exactly. And it's not just generative AI. We're also seeing more emphasis on low-code and no-code development,
Hmm.
which makes these platforms easier for more people to use.
So you don't need to be a coding expert
Mm,
to use data science.
right.
That's exciting. What other trends are you seeing?
Well, we're also seeing data science converging with other areas, like data engineering and MLOps, which is machine learning operations. Platforms are becoming more holistic, providing end-to-end solutions that cover the whole data lifecycle.
So instead of having different tools for each stage, we're moving towards integrated platforms that do it all. This is all really exciting, but also kind of overwhelming because the data science landscape is changing so fast. So how can someone keep up?
It's all about continuous learning, staying curious, exploring new tools and technologies, and don't be afraid to experiment. And remember, the best platform is the one that helps you achieve your specific goals.
That's a great takeaway. This deep dive has been so helpful. I feel like I have a much better understanding of the DSML platform landscape now. I feel more equipped to navigate this exciting and ever-evolving world. Any final thoughts?
The possibilities are limitless. What we've talked about today is just the tip of the iceberg. As you keep learning about this field, remember to always be curious, explore different perspectives, and never stop learning.
That's a great note to end on. Thanks so much for joining me on this deep dive. I hope you enjoy this exploration of the world of data science and machine learning platforms. Until next time, keep exploring, leave learning.
And keep pushing the boundaries of what's possible with data.
That's fascinating. It seems like these platforms aren't just competing, but they're also collaborating in a way. I guess it's all about finding the best combination of tools for the job. But how do they really stack up against each other? What are some of the key differences we should be aware of?
Yeah, you've hit the nail on the head. Choosing a DSML platform, it's not a one-size-fits-all situation. It really comes down to understanding your specific needs, resources, and goals.
Okay, so let's break it down. What are some of the key strengths and cautions for each of the platforms we've mentioned?
All right, let's start with Databricks. One of its biggest strengths is its unified approach. It combines data engineering, data warehousing, and machine learning into a single platform.
This is like a one-stop shop.
Yeah, exactly. And this can be a huge advantage for organizations that want to streamline their data workflows and avoid juggling multiple tools. However, some users find that managing Databricks clusters can be a bit complex and requires some specialized expertise.
So Databricks is powerful, but it might require a steeper learning curve for some users. What about Data Robot? How does it compare?
Data Robot's all about accelerating time to value for AI projects. They have a very user-friendly interface and a strong focus on automated machine learning. This makes it easier for business users with, limited coding experience to build and deploy models quickly. However, this ease of use can sometimes come at a higher cost compared to other platforms.
Interesting. So Data Robot's like the express lane for data science, but you might pay a premium for that speed. Now, what about Cloudera? What sets them apart?
Cloudera stands out for its flexibility. It works seamlessly across hybrid cloud, multi-cloud, and on-premises environments.
Wow, so it can handle pretty much anything.
Pretty much. This makes it a good choice for organizations with complex data architectures or those who are still transitioning to the cloud. One thing to note, though, is that while Cloudera offers low-code features, they're not as mature as some of its competitors.
So Cloudera is the adaptable option, but its low-code capabilities are still evolving.
Yeah.
All right, next up we have IBM's WatsonX. What's their story?
Openness and flexibility are key for WatsonX. It's particularly appealing for organizations already invested in the IBM ecosystem. It offers a wide range of tools and services that integrate well with existing IBM solutions. However, some users find their pricing structure to be complex and difficult to navigate.
So it's a good option for IBM loyalists, but maybe less transparent for newcomers. Lastly, let's talk about SAS Viya. What are their strengths and cautions?
SAS Viya is known for its scalability and its ability to handle large volumes of data. It's a robust platform that's been a mainstay in the enterprise analytics world for years.
Classic.
Yeah, you could say that. However, some users find that SAS Viya can be more expensive compared to other platforms, especially for smaller organizations or those with limited budgets.
Okay, so SAS Viya is built for handling big data challenges, but it might not be the most budget-friendly option for everyone. This is incredibly helpful. It seems like each platform has its own unique strengths and weaknesses, and the best choice really depends on the specific needs of the user.
Exactly. And it's not just about the technology itself. It's also important to consider the community and support surrounding each platform. Some platforms have more active user communities and offer better documentation and resources. And of course, a responsive and knowledgeable support team can make a huge difference when you encounter challenges.
That's a great point. It's like having a network of experts to help you along the way. This has been incredibly helpful. We've covered a lot of ground today, from defining what a DSML platform is to exploring the strengths and cautions of specific platforms. I think our listeners now have a much better understanding of the landscape. But before we wrap up, there's one more thing I want to touch upon: the rise of generative AI and its impact on data science workflows. So generative AI, it's like everywhere these days. What does it actually mean for data science?
Yeah, it's interesting. It's a big shift from analyzing data to actually creating it.
Okay.
Like we're talking about algorithms that can make text or images or even code and music.
Yeah.
It opens up so many possibilities.
So instead of just predicting what will happen, we can now use AI to see what could be right.
Right.
I'm curious about the real world stuff, though. Like, how is it used in data science? What are some examples?
Sure. So let's say you're building a model to spot medical conditions from like X-ray images, but you don't have enough real patient data to train it properly.
Okay.
Well, generative AI can create fake X-ray images that look just like the real thing. So your model has more to learn from.
Wow, that's incredible. It can help with data scarcity and privacy issues then, right?
Exactly.
What other applications are there?
Let's see. Financial modeling. Generative AI can create these realistic simulations of different market situations, so analysts can better assess risk and make smarter investment choices. Or in marketing, it can be used to come up with personalized content and product recommendations for customers.
So it sounds like generative AI could change a lot of different industries.
Oh, for sure.
But how are DSML platforms even keeping up with all of this?
They're changing too. Like Databricks, for example, they acquired Mosaic ML, which specializes in generative AI. So now Databricks users can train and use large language models way more efficiently.
That's a great example of how these platforms are adapting. It's like they're constantly getting new tools to help data scientists.
Exactly. And it's not just about generative AI either. We're also seeing a rise in low-code and no-code development, which makes these platforms more accessible.
So you don't have to be a coding whiz to work with data science.
Exactly.
That's awesome.
Yeah.
What other trends are you seeing?
Well, data science is kind of blending with other areas, like data engineering and MLOps, machine learning operations. And platforms are becoming more well-rounded. They provide end-to-end solutions for the whole data lifecycle.
So instead of separate tools for each step, it's all coming together. That's really interesting. It's a lot to take in. The data science world is changing so quickly. How can anyone even keep up with it all?
It's all about having that mindset of always learning. Stay curious. Look into new tools and technologies, and don't be afraid to try things out. Remember, the best platform for you is the one that helps you reach your goals.
That's a great point to remember. This deep dive has honestly been so helpful. I have a much better understanding of all these platforms now. I feel like I can actually navigate this world now. Any last thoughts before we wrap up?
The possibilities are truly endless. What we talked about is just the beginning. So as you explore data science further, always be curious, look at things from different angles, and keep learning.
That's some great advice. Thanks so much for being here. Hope you enjoyed learning about data science and machine learning platforms. And until next time, keep exploring and keep pushing the boundaries of what's possible with data.